Hello, everybody. This is Mr. Bowman. Today we're looking at the ALEX topic using the empirical rule, to identify values and percentages of a normal distribution. So what we're looking at here is they're giving us the two main parts of our normal curve. We're getting the mean and the standard deviation, and we're just trying to interpret those numbers today. So you're going to fill in three numbers down here at the bottom, and then at the end, you're going to choose the percentage of total area shaded, so the total area between those two lines. So hopefully you remember that a normal curve, mine will not be quite as nice as the one in the drawing because I'm drawing it myself as opposed to computer generating it, but it's not too bad. So remember, you have your mean in the middle, and then you have these standard deviations, which are the same distance from one line to the next. So this would be one standard deviation each way. Then we have two standard deviations and three standard deviations way out here. Okay, so then depending on how many standard deviations we went out, tells us how much of the data, so what percentage of the data is covered. If you're between the close ones, one standard deviation each way, this is 68%. Two standard deviations out is 95%. So all the way from here to here would be 95% of our data. And then stretching all the way from here to here, our last one is 99.7% of your data. So three standard deviations out. So we're going to use that information to do that percentage at the end. So let's start filling this in. They tell us the mean is 36.5. Okay, so that's right in the middle is 36.5. And then we need to figure out with the standard deviation of 5.2, so that's telling us the gap to each line is 5.2, then I need to figure out how far away I am. So if I do 36.5 and I add 5.2, right? Let's do 36.5 and plus 5.2. You could go either way. I like to add. Would take us to 41.7, so that's right about here. So that's not far enough, so I need to add 5.2 again, so which takes us to 46.9, which does look like that's what I want. If I added another 5.2, I'd go past 50, and I know my line, I don't know where it is exactly, that's what I'm trying to find, but I know it's between 45 and 50. So it's going to be two standard deviations then out to 46.9. And since I know that, I can go this way and do the same thing and figure out what's two standard deviations that way. So I go back to 36.5 and subtract my 5.2 this time. And I need to subtract it twice because it's going to be symmetrical. So I added it twice, so I'm going to subtract it twice. And that takes me to 26.1. Okay, seems reasonable, between 25 and 30. So those are my three numbers that I need. Now the percentage of the total area that's shaded, that depends on how many standard deviations we went. So in this case, we went two each direction, so that's 68, then 95. And this is a drop down, you're going to see these three numbers. But it is 95% because we went two standard deviations. If you went a single standard deviation, so we only went to here, it'd be at 68. If we stretched it out three standard deviations, that would be our 99.7. But we were at two, so this one ends at 95.